Dimensions, the building blocks of our universe. We perceive the world around us in three dimensions: length, width, and height. A point marks a location in space. A line extends in one dimension. A square lies flat with two. Our world is filled with three-dimensional objects like cubes. Imagine a flat, two-dimensional world. Its inhabitants can only perceive length and width. They would struggle to grasp a three-dimensional object passing through their world. They might see a series of changing shapes, but not the whole object. Now consider ourselves encountering a four-dimensional object. We might only perceive its three-dimensional slices as it intersects with our reality. These slices would appear to change and distort in ways our three-dimensional minds find hard to grasp. Beyond familiar dimensions, stepping into the fourth dimension. To understand the fourth dimension, we must stretch our imaginations beyond our everyday experiences. Mathematicians and physicists use the concept of a hyperspace to describe spaces with more than three dimensions. Think of time as an analogy. We can't see or touch time, but we experience it as a dimension. We move through it just as we move through space. Similarly, the fourth spatial dimension exists perpendicular to all our familiar three dimensions. Just as a two-dimensional world is bound within a three-dimensional world, our three-dimensional world may exist within a higher four-dimensional reality. While we can't directly experience this fourth dimension, we can use math and imagination to explore its possibilities. Unveiling the Tesseract, a cube unbound by our three-dimensional world. The Tesseract is the four-dimensional equivalent of a cube. Just as a cube is made of 6 squares, a tesseract is made of 8 cubes. These cubes are connected in a way that's impossible to build in our three-dimensional world. Imagine unfolding a cube like a cardboard box. You'd get 6 squares laid out flat. Similarly, unfolding a tesseract in our three-dimensional space would result in 8 cubes arranged in a specific pattern. While we can't physically build a tesseract, we can represent it mathematically and visually. These representations help us understand its properties and how it would appear as it intersects our three-dimensional world. Visualizing the unseen tesseract projections and transformations. Visualizing a four-dimensional object in its entirety is impossible for us. However, we can create projections like shadows of a four-dimensional object falling onto our three-dimensional space. Imagine shining a light on a rotating cube. The shadow it casts on a flat surface would change shape, showing different two-dimensional projections of the three-dimensional object. Similarly, a rotating tesseract would cast complex three-dimensional shadows that morph and transform as it moves. These projections can appear as cubes within cubes, cubes distorting and merging, or other intricate shapes. While these projections are only glimpses of the tesseract's true form, they offer a fascinating way to visualize higher dimensional geometry. Applications and implications. Where four-dimensional geometry meets reality. While the concept of four-dimensional objects may seem abstract, it has real-world applications. Physicists use higher dimensional math to describe the universe. Einstein's theory of relativity, for example, treats time as a fourth dimension, forming a unified spacetime. In computer science, four-dimensional geometry helps with data visualization and complex problem-solving. Imagine representing complex data sets with multiple variables as points in a four-dimensional space. This can reveal patterns and relationships that are difficult to see in lower dimensions. The exploration of higher dimensions also pushes the boundaries of our imagination and challenges our perception of reality. By venturing into the realm of the abstract, we gain new perspectives on the universe and our place within it. A final thought. The universe of exploration awaits. While the concepts may seem complex, remember that even the most groundbreaking scientific ideas often start with simple curiosity and a willingness to explore the unknown. We invite you to continue your exploration of the cosmos with us. Together, let's keep asking questions, seeking answers, and expanding our understanding of the vast and awe-inspiring reality we inhabit. Thank you for joining me on this journey through the fascinating world of four-dimensional objects and the Tesseract.